Alright, hello everybody, my name is Joseph Reuter and I'm doing my presentation on computational advertising. So to begin, just a little history of advertising. Advertising has been dated back to, Egyptian times when people used still papyrus leaves to write on, and there's been hieroglyphics found that have been selling, various goods, products, and services. Right here on the right we have an advertisement. It's during the Song Dynasty, 960 to 1279 BC. This is for actually a needle for sale, and then the left is a Coca-Cola ad from 1890, so it dates back a while. What is advertising? So advertising is any sort of marketing communication that promotes the sale of a product, service, message, or idea. And now there are various types of advertising. As you can see here, I just have a little photo. There's offline media, which is radio, billboards, TV, newspapers, all that conventional stuff, and then online, which is social media as well as search engines like Google. And it's further broken down into the two types, which are direct versus brand. So direct advertising is one of the major models in traditional advertising, and what it aims to do is elicit a direct response from the user. So an example of this I have shown here is sponsored search, where ads are shown alongside the web search results. The sponsored search on the web search and the web search are evaluated as two separate queries over different corpora, which means the former over the crawled web pages and the latter over the ads provided to advertisers. In contrast, we have brand advertising. Now, brand advertising on the web is usually done with graphical or display ads, which we can see here. And what brand advertising aims to do is more create a favorable impression of the brand or business instead of trying to get a direct response or direct purchase from seeing the ad. Now, some display advertising includes a direct response component where, as you can see here, you can click on the said ads and you can go and buy a product or service, but most of them are just for to promote the brand. So the difference between brand advertising and direct advertising is that display advertising, there's no explicit user query, so there's no really search results to base the ad on, and also selection is based on where the ad is placed, so just whatever page you get is the ad you're going to get. So moving on, we're going to talk about computational advertising. So computational advertising is a new scientific subdiscipline that takes all of these factors into play: information retrieval, search and text analysis, statistical modeling, machine learning, microeconomics, classification, optimization, and recommender systems. So why should one choose to use computational advertising? For one, we have classical venues, which are relatively few because you only have magazines, billboards, handbills, TV, etc. They're also at a high cost per venue. So, for example, think about airing a commercial during the Super Bowl. It's about $2 million for 30 seconds of airtime. There's no really personalization possible, so you can't really change the ad when you want to. It's what you have is what you get, and the targeting is done by an ad agency instead of an algorithm. And it's also hard to really measure your return on investment. You don't really have any correlation between people who saw the ad and the actual purchase being made. However, when you use computational, it's almost the exact opposite. There's billions of opportunities. You can be as creative and personalized as you want. There's a relatively low cost per unit compared to classical venues, and it's much more quantifiable. You can count clicks and see how many views an ad has versus how many purchases are made of a product online. So, how it works. Got a little info here. You just see the advisor going to the ad agency system, which then connects to a web page, therefore bringing you the web page and the ad together, which comes to you. So how it works, it's a process, and computational advertising uses keywords from the query itself to place certain advertisements and give them to the user. And they base this on, relevance, which is if the keywords actually match the query terms, bids by the advertiser, and also click-through popularity, which just measures how many clicks the actual ad itself has. And it's a measure of popularity. So one of the kingpins in this world is Google. And Google has its own software for creating and distributing these ads. So when you create, it's called Google AdWord, and it allows you to create the advertisements that will appear on Google search results web pages, while AdSense is the program that actually delivers the ad to the sites and then pays the publishers based on popularity and click-through numbers. So a basic model used by Google and Yahoo, in which the companies use partial information on browsing history to drive a recommender system and select ads to display, and a success measured through click rates and online purchases. So what searches for these advertisements is a crawler. Just like a web crawler searches for web pages, AdSense itself has its own crawler. And what the crawler does, along with the AdSense crawler, along with the web crawler, they search web pages for content and makes recommendations based on content. And the AdSense crawler is updated weekly, and it's performed automatically, so there's no request for frequent crawling. And it differs from the web crawler in the fact that the two crawlers are separate, but they share the same cache, so the same pages aren't requested, and it helps the publishers conserve bandwidth. And we're going to move on to recommender systems, which sort of ranks or filters these said ads based on certain criteria. So a recommender system has many names. It can be a recommender platform, engine, but all of them together are a subclass of information filtering systems, and they seek to predict a rating or a preference that a user would give to them, like to give to a product or to give to a service. And recommender systems have become extremely common in recent years and are utilized in a variety of areas. And some of the popular would be, recommending movies, music, news, books, research articles, and the list goes on. So one of these filtering techniques is called collaborative filtering. And collaborative filtering methods are based on collecting large volumes of data on user behaviors and activities or preferences, and predicting what the users will like based on their similarity to other users. So a key advantage to collaborative filtering is that it doesn't really rely on machine analyzable content. Therefore, like if it's trying to recommend a movie, it doesn't really need to understand what a movie is. It just needs to understand that it's related to other people's likes. And one of the examples that they use in this method is they use k-nearest neighbor approach. Content-based filtering. It's another common approach to designing recommender systems. And what it does is, based on the description of an item and a profile of the user's preferences, it recommends ads to the user. So in this system, they use keywords to describe the items, and a user profile is built to indicate the type of item the user actually likes. In other words, these algorithms try and see what a user has seen in the past and seen in the present and make recommendations based on this. And this has its roots in information retrieval and information filtering, because basically the methods that are used to characterize the item in the system creates, as I said before, a content-based profile and that of users based on a weighted vector of items and features. The weight denotes the importance of each feature to the user and can be computed from individually rated content vectors using a variety of techniques. So simple approaches to this can use an average of these vectors, and then even more sophisticated versions can use Bayesian classifiers or cluster analysis or decision trees or even artificial neural networks in order to estimate the probability of someone liking a certain item. Now, there are some that actually combine both techniques of collaborative and content-based, and they're called hybrid recommender systems. So as you can see here, you have two input, two different filtering techniques, some sort of combiner, and then a recommendation coming out. So recent research has demonstrated that a hybrid approach can be more effective in some cases. So a hybrid approach can be implemented in several different ways. You can make, content-based decisions first, and then collaborative-based. Separate the two, and then combine them to make one recommendation. You can add collaborative to content-based, or vice versa, or you can make a unified model that uses both together. And there's a pretty good example of this that we all know. Netflix actually has a hybrid recommender system because the website makes recommendations by not only comparing and the watching and searching habits, which is a collaborative filtering method, but it also offers movies that share characteristics with films that a user has rated highly, which is content-based filtering. So where do we see the future of computational advertising? We have many stakeholders that are actively researching the future of computational advertising, especially social networks. As I'm sure everyone who has social network has seen, there's a lot of advertisements on Snapchat, Twitter, Instagram, Facebook, even like YouTube, and these companies in particular have, been trying to use computational advertising to extract, obviously more profit for themselves from the users. But this can cause some issues for some people, and they're being expressed by individual web users. So for one, the data usually that comes from, say, Google AdSense and all those kind of things is usually proprietary, so the public really doesn't have any access to this data, and will really never know exactly how the organizations use or exploit the data for profit. So individual web users are having an increasingly important influence on this debate and the way their information is exploited for profit. So many individuals are actually removing details about themselves and taking measures to prevent advertisers from identifying them, such as, say, blocking your cookies. I even have an example that's personal to me. My computer science TA won't even use Google because they take so much information from you and don't really tell you what they're doing with it. And this is going to be a running battle that is unlikely to be settled soon. So here's my references, and that's the end. Thank you.